Bismillahirrahmanirrahim. I am Fawad Ali, Assistant Professor, Department of Pharmacy, Port University of Science and Technology. Welcome to the course Pharmacology and Therapeutic. Today we'll discuss about the principle of toxicology, the study of the poison. In today's lecture, we discuss we will discuss about the principle of toxicology, its contents like poison, subdiscipline of toxicology, from exposure to toxicity, dose and toxicity, what is a response, measure of toxicity, the median lethal concentration, relative toxicity, lecture outcomes. After watching and listening, the student will know about the principles, the basics of toxicology. The study of adverse effect of a toxicant on a living organism. Toxicant, also known as a poison, any agent capable of producing any agent capable of producing an adverse effect in a biological system. Adverse effect, any change from the organism normal state. Depend upon the concentration of the active compound at the target site for the sufficient time. What is poison? All substances are poison according to the Paracelsus discussed in the molecular mechanism of toxicity. Define the Paracelsus define the poison that all the substances are the poison. There is none that is not a poison. The right dose differentiate the poison and the remedy. So basically, the limiting the rate limiting step is the dose, the right dose, which will differentiate between a poison and remedy. So sub-disciplines of toxicity. There are different disciplines of toxicity like environmental toxicity. Discuss the toxicants in the environment, uh, and the occupation industrial toxicity. Discuss about the industrial toxicants. These are some regulatory toxicology, which will, there are some regulators which will make guidelines, rules and guidelines for how to manage this toxicity. Food toxicity, like define the food toxicants, its effects and how to manage these food toxicants. Clinical toxicology, like how clinically how to manage toxicant. Descriptive toxicology, forensic toxicology, analytical methods, analytical methods and essays to identify toxicology. To mechanistic toxicology basically is to find the mechanism of the toxicity. So these are some disciplines of the toxicity. Classification of the toxicant agent, like there are the heavy metals, solvents and evaporators, radiations and radioactive materials, dioxin, furans, pesticides, plant toxin, animal toxin. There are different type of the toxicants here, like animal, heavy metals, solvent, vapors, radiation, radioactive materials, dioxin, furan, pesticides, plant toxin, etc. Subcategories for the classification, like their effect on the target organs, like liver. They are basically classified on the organ. They can be classified on the organ. It's like toxicant affecting the liver, toxicant affecting the kidney, like hematopoietic system, etc. They can be classified on their use like pesticide toxicants, solvent toxicants, food additive toxicants, or the source of the agents like they are classified as animal toxicants and plant toxins, etc. Their effects like cancer mutation, liver injury, etc. Like we classify on the physical state like gas, dust, liquid, etc. Labeling is required for the explosive, inflammable, and oxidizer. Chemistry also play important roles. It can be classified on the basis of its chemistry. More general classification for the communities like there is air pollutants, occupation relating agents, acute and chronic poisons. So these are the more general classification like toxins in the air pollution, whether it's environmental, they are from industrial, from waste product of industrial and other. Occupational relating agents, they are like working environment, and acute and chronic poison, like some poison are acute, some poison chronic toxicity. Places where you can get information include like electronic databases, like toxicology database, ToxNet, ChemTrack, Chemical Transportation Emergency Center, MedTrack like Medical Transportation Emergency Center, Material Safety Data Sheets, hazard substance health effect database. So there are different databases where you can get information regarding your the toxicity. Different online databases. From exposure to toxicity, like exposure, apply dose from outside. Exposure is the apply dose from outside. Internal dose, absorption is the internal dose. Distribution, target organ dose. So biological effect, biological changes, symptoms, health effect, obvious, health effect may be obvious, not so obvious, specific, non-specific, late disease. So exposure to toxicity, for example, for like dose and toxicity, amount, timing, pattern, and duration. Amount, timing, pattern, and duration. Health effect depend upon the exposure and susceptibility of the individual or population. So health effect depend. This is the total dose and toxin amount, timing, pattern, duration. Health effects it depend upon its exposure, time of exposure, susceptibility of the individual, how it is susceptible to the individual or the population. Okay, it also depend upon the interaction of the genetics, like genetic variations, nutrition, socio and environment, cumulative exposures. One chemical may have a variety of health effects that occur at different doses, timing and pattern of exposure. So like for example, one chemical have many variety of health effects that occur at different doses, so timing and pattern of exposure. For example, we have a drug digoxin. Digoxin is a cardiotonic drug used specifically to increase the cardiac output, specifically in the congestive cardiac failure. So this substance have a different mechanism of action at different doses. Like at low doses, they form parasympathomimetic effect. They show parasympathomimetic effect, cholinergic like activity. At the high doses, they show a sympathetic activity, sympathomimetic activity. So, like for example, it is used in case of the arterial fibrillation, sinus tachyarrhythmias, etc. But it causes ventricular tachyarrhythmias at high doses. So, so dose and it depend upon the dose. Okay, what is dose? The amount of chemical entering in the body. This is known as the dose. The amount of the chemical entering the body. This is usually given as mg of chemical per kg of body weight. The dose depend upon, like this is upon like mg of chemical per kg of weight. The dose depend on the environmental concentration, the properties of toxicants, the frequency of exposure, the length of exposure, and the exposure pathway. This depend upon like environmental concentration, toxicant properties, frequency, exposure, length, and pathway. Those depend upon the following parameters. What is response? The degree and the spectra of responses depend upon the doses and the organism. Describe exposure condition with the description of the dose. So the degree and the spectra of responses depend upon the dose. They depend upon the dose and the organism. Describe exposure condition with the description of the dose, which describes the exposure condition with the condition of dose. So response depend upon the two things like the dose and the organism. Like changes from the normal state could be on the molecular, cellular, organ or organism level. The symptoms may appear. Local versus systemic response should must be, yeah, maybe local or systemic, like they are reversible or irreversible. Like for example, in case of the local anesthetic they have local effect, for example, versus systemic like general anesthetic reversible, like no, most NSAIDs have reversible blockage of cyclooxygenase pathway. Aspirin is a non-selective COX inhibitor but will irreversibly bind with the um, combined with the COX inhibitor. So immediate versus delayed. There are some drugs they are acute, they are effective and they have immediate effect. Some have the delayed effect. Most of the drugs like antidepressants, they are most commonly they have delayed effect. Some drugs have immediate effect like captopril, enalapril. These are the ACE inhibitor specifically used in to reduce the high blood pressure. Graded versus quantal. So degree of the some damage versus all or none. So response depend upon the dose and organism, which is describe the exposure condition with the description of the dose. It may changes from the normal state. Maybe it may be molecular, cellular, and so on. So the effect response may be local, systemic, reversible, irreversible, immediate, delayed, quantal, or graded wise. So this is a dose response curve. As the dose of toxicant increases, so the response, like dose of the, it is a, like this is the like dose of the toxicant increases, the response increases. So this is known as the dose response curve. Graded dose response curve. So there is a lag phase. 2, 3 is a linear range, and the 4 is a maximum response given by the toxicant. Measure of toxicity. Toxicity of the chemical is determined in the laboratory. The normal procedure is to expose the test animals. Like the toxicity of the chemical is determined by the in the laboratory. The normal procedure is to expose the test animals by ingestion, application to the skin, by inhalation or some other method which introduces the material into the body, or by placing the test material in the water or air of the test animal's environment. By ingestion, application to skin, by inhalation or some other method which produces the material into the body, or by placing the test material in the water or the air test animal's environment. Measure of toxicity is the measure as a clinical endpoint which include mortality, teratogenicity, ability to cause the birth defect, carcinogenicity, ability to cause cancer, mutagenicity, ability to cause heritable changes in the DNA. At this time, we will discuss two measures of mortality like the LD50 and the LC50. Measure of toxicity, the median lethal dose, LD50. It is the amount of the chemical which produces death in 50% of the population of the test animal to which it is administered by any of the variety of methods. Basically, the amount of the dose of the chemical which produce in 50% that's 50% of the population of the test animals. It is measured in the milligram per kg, normally expressed as milligram of the substance per kilogram of the animal body weight. So this is like, for example, at dose of toxicant increases, so the response also increases. So lethal dose is the at the dose where the 50% of the population for the causes 50% population death, LD50. LC50, the median lethal concentration. So it is a median lethal dose, it is a median lethal concentration. The concentration of chemical in an environment, generally air or water, which produces death in 50% of exposed population of test animal in a specific frame of time. So they are measured in the milligram per liter, normally expressed as milligram of substances per liter of air and water. Units used to measure the chemical in the environment. They are like part per million, ppm, part per billion, ppb, part per ppt, part per trillion. So these are used to measure the chemicals in environment, which means that 1 cc is equal to 1 ml is equal to 1 milligram. 1 liter of water is equal to 1 kg of. So 1 milligram per kg is equal to 1 ppm, part per million. 1 milligram per 1 meter cube per liter is equal to 1 ppm. 1 milligram per liter is equal to 1 ppm. 1 microgram per liter is equal to 1 ppb, 1 per part billion. So comparison, like LD50 comparison, there are some chemicals having the LD50 milligram per kg, like ethyl alcohol is 10,000 milligram per kg, sodium chloride is 4,000 milligram per kg, ferrous sulfate 1500, morphine sulfate 900, strychnine sulfate 150, nicotine is 1 milligram per kg, black widow 0.55, curare, rattlesnake 0.24, dioxins, botulinum toxins. So legally defined terms, not just anything you don't like. Poison is a legally defined term, not just anything you don't like. Any pesticide with an LD50 or 50 milligram kg or less. Label must reflect this classification. Like they have a label, the poison must be. Label must have the single word danger plus the word poison. Label also must display the skull and the crossbone icons. Relative toxicity: organism cannot differentiate between natural and the synthetic chemicals. Synthetic does not mean it's toxic or poisonous. Natural does not mean safe or even low risk. Chemical must be evaluated in their biological context of behavior in organisms. Mode of action, not source, is the concern of toxicologist and informed user of pesticide. Related toxicity: most herbicides act on a biological pathway not present in the humans. Those approved for the use in the region much more about than they later have LD50 or of 50 mg per kg or greater, they have intermediate or relatively low toxicity. Some of the insecticide used are highly toxic. Relative toxicity like dioxins are 0.1 mg per kg, nicotine 50 mg per kg, carbaryls 270 mg per kg, malathion 370 mg per kg. So there are some uh, related toxicity herbicide relative like paraquat 95, 240, 375, triaclophyr 360. There are different type of the herbicides and they have relative toxicity on the basis of milligram per kg. Like kerosene have 1828,000 milligram per kg, and this is diesel oil 73.5. So limonene 5,000, chlorpyrrolate 5 greater than 5,000. So there are some relative toxicity on the basis of milligram per kg comparatively. Okay, they are like highly toxic compound ranges. They have a relatively low LD50, like 0 to 50 milligram per kg range is 1 teaspoon, 1 milligram per kg. Botulinum toxin, digoxin, parathion, strychnine, nicotine. They are relatively higher toxic. Moderate toxins which have the range of 50 to 500 milligram per kg range, like teaspoon 1 ounce like per kg, like paraquat, caffeine, carbamyl, etc. A slightly toxic compound, they have the range of 500 to 5000 milligram per kg range. So there are some compounds they have slightly toxic as compared to, because they have high margin of safety as compared to the having a higher LD50. So these are some compounds they have higher margin of safety. So relative toxicity: are all substances toxic? Yes, all toxic to some quantified degree. So sugar have an LD50 of 30,000 milligram per kg. So the Forester favorite ethanol has an LD50 of only 13,700 milligram per kg. Even water has a recognized LD50 of slightly greater than 80,000 milligram per kg. So radiotoxicity: the last word. Pesticides are the chemical induced into the environment to perform a function. The source of the chemical, synthetic versus natural, is irrelevant while considering its toxicity. Pesticides should be treated with care and proper respect, but so should household cleaner, gasoline, kerosene, bleaches, paints, and all other chemicals. Thank you so much.